Hi friends, I hope you are doing well. Myself Abhishek Tripathi and I came across with another set of interview question, Virtusa first round. So I am going to start my question what they have asked. So first question they have asked, have you worked on Hive and AWS services like S3, Lambda, EMR and etc? So I simply told, yes, I worked with Hive and AWS 3 where you are running your Spark job. So I simply told Databricks, I am running the Databricks environment. My code is reside in Databricks. We are running our jobs in Databricks, but using Airflow DAG. Through Airflow DAG triggered the Databricks notebook and it start and complete the our jobs. So another question they have asked, on which environment your Databricks configure tell me the cloud name or cloud name. So simply told our project is configured on the AWS environment. Then he asked what happened when you will submit Spark application. So simply I inform that when we first it will initialize Spark context. The initialize Spark context means the Spark submit process initiate a Spark context based on the configuration provide in your application code and command line argument. So either you want to run through the command line argument like this, either you can use interactive mode, means front end. Yeah, it is dependent you. The Spark context serve as the entry point of to all Spark functionality. Then another part is packaging in application code. So if your application code in Scala and Java, Spark submit compiles your code into bytecode and package it into a jar file along with the necessary dependencies. If you are submitting a Pyspark application, the necessary Pyspark libraries are bundled on there. Another thing happen will sending a cluster manager the package what jar whatever it are PySpark files and application configuration are sent to the specified cluster manager, either yarn or stoneline or kubernetes, using the cluster manager API. Once it is done, then cluster manager resource allocation, then cluster manager allocates resource for the driver program, and if specified for the Spark executor based on the resource you requested in the Spark submitted submit command. Whatever you have requested, it will give the same configuration on there. So after that, launching driver program. Another part is on the on one of the allocated node, whatever given by the cluster manager launch the driver program. The driver program run the main function of your application and initializing the Spark application. Then setup of environment. The driver program set up the environment for the Spark application. This includes setting class path, environment variable, and initialize configuration. Then break into the task. Then Spark break down your application high level logic into smaller unit of work called task. Each task is designed to prepare or designed to operate on a specific data partition, enabling parallel processing. Then after that, executor will launching of executor. The cluster manager launches executor process on worker node. The executor and JVM process responsible for executing task and managing data partition. Then another part is came task scheduling. The driver scheduled the task to run on available executor based on the data locality and resource availability. Spark employs a DAG, that means a directed acyclic graph schedule for optimized execution. Once this done, then another will task execution start. Executor type task from the driver program and execute them in a parallel on a available data partition. Task apply transformation and action defined in your Spark application code, whatever you have written. In memory data processing, so Spark optimize performance by processing data in memory where possible. In memory operations, speed up processing by reducing the need for disk and IO input and output. So after that, data shuffling and transformation. The transformation like group by, like join or reduce by may require data shuffle. So data shuffle involve a redistribution and recognition data across partition, which can be resource intensive. Another, after that, result aggregation. After that, result aggregation, the result of transformation and action are collected and generated to provide the final output. Aggregation might involve combining part partial result from different partition. So after that, fault tolerance mechanism, you know the fault tolerance mechanism. Spark resilient nature ensure fault tolerance. If a task fail, it can be executed on another executor using a lineage information. So lineage track the sequence of the transformation that produce a partition, enabling the computation if needed. After that, resource cleanup. Once all are completed, the driver program and executor process release their allocated resource. Then last application terminated. The Spark submit process receive the final output or any application specific logs. The process terminate and the Spark application concludes. Your process completed, all full process. This way it will complete. Then another question he has: after running the job and when you see the DAG will be found, multiple stages are created. Can you tell me how stages are created? So simply, when we are working with Spark, stages are created based on the shuffle boundaries in the execution plan of the job. The jobs transformation jobs transformation operation like map, filter, reduce are split into stages, and the creation of the stages driven by the narrow and wide transformation. First, you know the what is the narrow transformation. So narrow transformation, these operation where each partition contribute to exactly one output partition like map, filter, and flat map. Since there is no need to reshuffle or reorganize data across partition, narrow transformation can be pipelined and executed within a single stage. Another part, wide transformation. These are the operation where data from multiple input partition is required to compute an output partition like group by, reduce by, and join. These operations involve shuffling, which means that the data need to be redistributed across different node or partition. After that, there is another part, narrow and transformation stage based on the shuffling. So stages are determined by the point where shuffle operation occur. When Spark encounter a wide transformation which requires shuffle data between partition, it create a boundary and a new stage is started. Each state consists of a set of tasks that are executed independently, one per partition. So I'm going to give the example how it is going to work. So suppose this is the data frame spark.read.csv. There is no it is create you have read, then you have apply the filter narrow in the say then you have apply the filter. So here there is no stage. Here after read, there is a one, it is going to work in the same stage. It is going to work in a same stage, that is a same partition, whatever is going on there, same partition on there. Then we are going to perform the group by, then white transformation. We are doing the white transformation, then shuffle required. Here shuffle required. Again we are doing the narrow transformation filter. So here shuffle is not required. The filter age is greater than operation is a narrow transformation, so it does not require a stage boundary. The group by age requires shuffle to recognize data, creating a stage boundary and result in a new stage. The final filter is again a narrow transformation, so it is pipelined with the second stage. So how stages are created, main question is there. Spark groups consecutive narrow transformation together into a single stage. Only when a wide transformation is encountered does Spark divide the DAG into a new stage. So each stage is a set of tasks that can be executed independently in parallel across the cluster. The number of stages in a job depend on how many wide transformation are present in the DAG. So each wide transformation will start a new stage. So example, DAG with stages. Consider same example you have seen next, reading file CSV, then doing filter narrow transform, then doing map narrow transformation, then we are applying join, that is a white transformation, then we are applying select, that is a narrow transformation, then again we are applying the group by, this is the white transformation, then after we are doing this show. So in this case the job would result in the following stage: execute all the narrow transformation, read, filter and map. First these three, it will create a one stage. Then after that I have applied the join transformation, second one join. So execute the first white transformation, join. This is stage start of the shuffle. Again we are using a select. The select is a nothing but a narrow transformation. It combined with the it combined with the second stage on there. Again we are performing the group by, it will form a new it will form new stage on there. So execute the second white transformation group by, this stage start after the shuffle. After that, once it will done, once it will done, the each of the stage is a logical unit of execution within Spark, means DAG of stages, and the task within a stages are executed parallel across the cluster. So fifth factor is that factor influencing stage creation. So shuffle, any operation that trigger a shuffle such as a group by, join, repartition or reduce by will create a new stage. Partitions, tasks within a stage are running in parallel, one per partition. Increasing or decreasing the number of partition can affect task distribution but does not directly influence the creation of a new stage. Action, the actual execution of a stage happen only when an action is invoked, like so, collect, write. In summary, stages in Spark are created based on the presence of the white transformation that trigger a shuffle. Spark tries to group as many narrow transformation as possible into a single stage, and the DAG show the sequence of the stages, each repartition and set of the parallel task. Now another question they ask, what is the explode function? What is the explode function? So explode function in Spark is used to transform array or map column into multiple row. So essentially, it flatten a complex or nested structure by generating a new row for each element in the array for each key value pair in the map. This function is particularly useful when dealing with the nested data like JSON structure, and you want to work with the individual elements within an array or map. Key feature: array explode, create a new row for each element in the array. Maps explode, create a new role for each key value pair, splitting the key and value into separate column. So I'm going to be the example. Exploding an array column in Pyspark. When you have a data frame with an array column, explode will flatten the array into individual rows. So example, let's create a data frame with an array column and use explode to flatten the data. So I have imported these three libraries like pyspark.sql.import spark session. Then from pyspark.sql.functions import explode. So in initializing the Spark session, so Spark session builder app name, I am giving the app name whatever I have initializing the Spark session. Then I'm creating a sample data for array, like there is a one key and value. So one key is one and contain the apple, banana, cherry, and keys two contain the orange and peach. So I have created the data frame based on that ID and fruits. Then I have shown this to you on there. So explode. If I'm going to apply the explode function, so what will happen? Select df.select id calling and explode fruits alias as a fruit on there. Then I am doing this. You can see that the for id one apple, one banana, one cherry, two orange, two peach on there. In this example, the fruit array is explode into the individual row for each fruit which the corresponding id retained for the each row. Now exploding a map column in a PySpark, when working with a map column, explode will create one row for each key value pair in the map. So example, how you can use explode on a map column in Pyspark. So from Pyspark SQL.function import explode. So you can see that this is the map column, like in a dictionary format. Here you can see that. So this is the value. If I'm going to apply the explode on a map column, an aliased key and value, so you can see the output like this. In this case, the map is explode so that each key value pair become a separate row. So exploding and explode outer. So I'm is the explode outer function is variation of explode that return null for row where the array or map is null or empty. This is useful when you want to return a row that would otherwise be discard with explode. So from pyspark.sql I am importing the explode outer instead of explode. So here you can see that first value I am going to enter like one id and fruits name, second two and giving the none as a null array. So I'm creating a data frame and this is the data I have to do explode outer. Then I have applied the explode outer, you can see that, and found that the second column is contain the null. So summary is that explode flatten the array or map into individual rows and discarding null arrays map. It is not accepting null value. You keep in mind in explode outer, similar to explode, but return rows with the null arrays also. Both functions are useful when working with a nested or hierarchical JSON and are frequently used in data processing and transformation in the PySpark. Another question he asked, have you worked on JSON format? So I told him, yes, I have worked with a JSON format. So he asked, suppose we have a JSON with a multiple line, multi-line, multiple. We have a JSON with a multi-line, not a single line. What parameter you have to enable in Spark session while reading your JSON file to avoid error? Otherwise it will throw an error. So when we are dealing with a JSON file that contain multi records, so we have that contain multi record in PySpark. So you need to set the multiple option to multi-line option to option to true when reading the data JSON file to avoid error. Without this setting, Spark will affect each line the file to be a complete JSON object and it will throw an error if a single JSON record span multiple line on there. So this is the example. You can see that this is the JSON file, multi-line JSON file. And now if I'm going with that, then your PySpark code should be given below. From PySpark SQL.import session, I have created a import session. I have created a Spark session, imported the Spark session and created the Spark session and here I am reading the data and then you can see that I have enabled in option, I have enabled the multi-line true, and then I have given JSON, I have given the JSON path name, then I am then I'm doing df dot so key point is that multi-line set the option to true to tell Spark that the JSON file contain record that span multiple multi-line. Default behavior, by default Spark reacts each line to be complete JSON object, and without the multi-line option it will throw an error when encounter a multi-line JSON file. So thank you very much. This is over for today. For this is the first round interview question. So thank you very much for watching. Keep like, keep subscribe, keep share my videos. Thank you very much.